Everyone. In this video, I am going to explain about how to find the first address and last address of a network or a subnet. So there are two methods to find the first address and last address as well as the range of address in the block. So there is in this example, a block of address is granted to a small organization. We know that one of that address is 205.16.37.39/28. So this is the subnet mask. So this range of address, it is comes under the class C type. So there are five classes: class A, B, C, D, E. So for class A, the range of addresses starts from 0 to 127. And for class B, it starts from 128 to 191. And for class C, it starts from 192 to 223. So this is the range of address. And class D and E are that normally we are not use the type of addresses here. So normally we are using class A, B and C. So as I told, for class C, the range is 192 to 223. So here it starts with 205. So definitely it comes under the class C. So for this address, in your organization, this is one of the address. So for organization or a small network is there. So in that network, this is one of the address. What is the first address and last address we have to find? So first address, first you write the IP address whatever given 205.16.37.39. The binary representation of these addresses, in the previous video I explained how to convert binary to decimal and decimal to binary. So now we are converting this IP address into binary notation. So 205, for 205, the binary number here it is 11001101, and for 16 the binary number is 0001 and for consecutive four zeros, and for 37 001 001 and for 39 001 001 So this is the binary representation of this given IP address, which is in decimal notation. So now we have to find the first address. For that, the given subnet mask is 28. The total length of the IPv4 address is 32. So here we subtract that IPv4 address with the subnet mask. Here it is equal to 4. So what we are going to do here means, so in this binary notation, we have to change the rightmost 4 bit. So this is the rightmost 4 bit 011. We change this rightmost 4 bits to 0. So after changing this rightmost 4 bits to 0, this is the binary notation. So for the first three octet, there is no change. So it comes as it is 205.16.37. But in the last octet, the last four bits are changed. Already 0 means no issues. We can write 0 itself. Anyway, for the last four bits here, we can change it as 0. Only the 1, it is in the position of 2 to the power 5. So for 2 to the power 5, the decimal value is 32. So this is the first address of that network. And for last address, how we can find means do the same thing. We have to write the binary representation of the given address. The binary representation already we know. So write the binary address as it is. For first address, we change the last 4 bits. Why we change the last 4 bits? The total IPv4 address is 32 and the given subnet mask is 28. So 32 minus 28 is 4. That's the reason we are changing only the last 4 bits to 0 for first address. But for last address, we change the last 4 bits to 1 here. The rightmost 4 bits to 1. After changing the rightmost 4 bits to 1, this is the binary number for the last octet. So that is similarly here. Here also there is no change in the first three octets. So it comes 205.16.37. But in the last factor, there is some changes. So we add the place value of 2 to the power 5, 2 to the power 3, 2 to the power 2, 2 to the power 1, and 2 to the power 0. After adding all these value, we can get it as 47 here. So this is the last address of that network. First address we know and last address we know. So in between these only, here they are giving the address it as 39. So 39, it is placed in between 32 and 47. So this is the first address. First address is nothing but the network address of that network. And this is the last address of the network. We name it as broadcast address of the network is this one. So how many number of addresses available in this network? For that, we can find that by 2 to the power 32 minus 28 2 to the power 4. So total 16 addresses are available in that network. So from 32 to 47, total 16 addresses are available in this network. So this is one way to find the first address and last address. There is one more method to find the first and last address. So in that, the same question, whatever the question we discussed in this topic, so the same question I take here, 205.16.37.39/28. So binary notation of the given IP address already we know. So write the binary notation of the given IP address. So the same address, there is no change in the address. So this is the IP address of this decimal number. And next, write the binary notation of the subnet mask. Here mask is nothing but the subnet mask 28. So for this 28, first three octets 24 bits are 1 here. So the remaining 4 bits 1 and the last 4 bits are 0. So this is the binary notation of the subnet mask. 8 bits plus 8 bits plus 8 bits plus 4 bits here. So total 28 bits. 28 bits is the subnet mask. The value of that 28 bits is 1. The remaining last 4 digits are 0 here. Last 4 bits are 0 here. And for finding first address, here we are performing the AND operation. In AND operation, if both the values are 1, then the result is also 1 here. If any bit is 0 or both bits are 0, then the result is 0 here. So here for the last 4 bits, here it is 0. So all the 4 bits are 0 here. But in the sixth bit, both values are 1. So here it is 1. 0 plus 1, 0. 0 plus 1, 0. In AND operation, both bits are 1 means the result is 1. Here both bits are 1, so the result is 1. Here one bit is 0, so it is 0 here. Here both bits are 1, so 1. Similarly, we can write the remaining bits. Anyway, here also there is no change in the first 3 octets because here the mask value for the first 3 octet is 1. For all bits it's 1. And if you are performing the AND operation with the IP address, whatever the IP address, it will return as it is. Only the changes it it occurs in the last octet. So here the decimal value of the last octet is 32. The same thing whatever we find here. Here also it is 32. This is the next method. In this method, only the last 4 bits we can make it as 0. In this method, binary notation of IP address and binary notation of the subnet mask, and then performing the AND operation. So similarly for last address, this is the binary notation of the given IP address, and in the first address we write the binary notation of the subnet mask. But here we can take the complements of the subnet mask. Complement means we can make 0 to 1 and 1 to 0. So here this is the mask binary value, subnet mask binary value. So here we are taking the mask complement. So ones are changed into 0. So first 3 octet all bits are 0 here. First octet all bits are 0 and second octet again 8 bits are 0. Third octet again all 8 bits are 0. In the fourth octet, first 4 bits 1 becomes 0 here and the last 4 bits, rightmost 4 bits, the 0 becomes 1 here. So this is the complement. And one more thing, in the first address we are performing the AND operation. Here it is OR operation. OR operation means if any one bit is 1, the result is 1 here. And also both bits are, in both bits are 1 also 1 here. If both bits are 0 only 0. For the remaining all bits it is 1. Here both bits are 1, 1 here. Here also 1, 1. So performing OR operation 1 here. 1, 1. Here also 1. If any one bit is 1, 1 here. Here in the first bit it is 0 here, but it is 1. So 1 comes here. But in this condition, both the bits are 0. So 0 comes here. Here 1, 1 is available in the IP address. So result is 1 after performing OR operation. Similarly, we can do the same thing for the remaining thing. Here also there is no change in the first 3 actors. So the 205 16 dot 37 dot, the last actor it is 47. So in a network configuration of the block is first address is 205.16.37.32. This is the first address. And the last address is 205.16.37.47. This is the last address or broadcast address. In between, the remaining addresses are available. This is one block or this is one network. So in this network, 16 addresses are available. Thank you.